Swayam Prabha. Digital India. Educated India.
In units 3 and 4, we have looked at elements connected in series and parallel, and also in the use of control sources. I will show a worked out example involving these aspects, and this is the kind of problem that you expect in the assignment for these 2 units. Now let's take a very simple case. A circuit like this with 2 resistors in series, and any kind of question can be asked about this. For instance, one could ask you what the equivalent circuit is between the nodes A and B. It clearly looks like a resistance of 3 kilo ohm, because we have already discussed this, that a series combination of a number of resistors simply looks like the sum of all the individual resistors. Now we could complicate this circuit by having another resistance in parallel. Okay. So again, there are a number of ways to solve this, but the easiest is you recognize that we have a parallel combination here. Okay. And that parallel combination looks like a single resistance. Okay. Now, if I call this the effective resistance, 1 over R effective will be 1 by 2 kilo ohm plus 1 by 8 kilo ohms. By the way, for 2 resistors in parallel, you are probably already familiar with the formula. If R1 and R2 are in parallel, they result in a single resistance value R1 R2 by R1 plus R2. Okay. This comes from the general relationship we evaluated earlier, that the reciprocal of the effective resistance is the sum of reciprocals of individual resistances. Okay. So if you calculate this, in this case, R effective turns out to be 1.6 kilo ohms. So this entire combination equals 1.6 kilo ohms, and in series with that we have this 1 kilo ohm. So in the new circuit, when we have the 8 kilo ohm resistor also, we have an effective resistance of 1.6 plus 1, which is 2.6 kilo ohms. Okay. So quite simple. Now I'll show another simple example with control sources. Okay. Now let's say this is A and B, and I'll still ask the same question, what is the resistance between A and B? But the actual question could be something else. You could have a voltage source there, and you could be asked to find some current and so on. All those can be carried out equally easily. Okay. Let me define this voltage as Vx, and I'll define a voltage controlled current source, which is 1 millisiemens times Vx. And again I ask, what is the equivalent between the nodes A and B? And this is the standard way for finding the equivalent for any circuit. Apply a voltage and find the current. Of course, you could apply a current source and find the voltage. In this case, I'll consider applying a voltage. Now, clearly, if I have a V-test, it's applied across this series combination of two resistors. So, the current that flows here is given by V-test divided by the total resistance between these two. I'm only looking at this series branch, which consists of these two resistors. So that will be V-test divided by 3 kilo ohms. And this Vx would be the current flowing through that times the voltage, which is Vx V-test divided by 3 kilo ohms times 2 kilo ohms. Okay. Which is V-test times 2 by 3. This is nothing but the voltage divider formula, which you're most likely familiar with. If I have V and R1 and R2, across this I'll have V times R2 by R1 plus R2. Okay, so that's exactly what I get. And the way to derive this formula is to realize that current through this is V divided by R1 plus R2, and that current times this resistance is the voltage across R2. Okay. Then this controlled current source draws a current which is basically 1 millisiemens times Vx, which is 1 millisiemens times V-test times 2 by 3. So all I did was to substitute the value of Vx in this place. Okay. So now the total current I test is equal to the current flowing here plus the current flowing there. So I test will be equal to V-test divided by 3 kilo ohm plus 1 millisiemens times V-test times 2 by 3. Okay. Therefore, V-test by I-test will turn out to be 1 by 3 kilo ohms plus 1 millisiemens times 2 by 3. Okay. Which this part you realize is 1 by 3 millisiemens. So this is 1 by 3 millisiemens plus 2 by 3 millisiemens. Okay. So the effective resistance between A and B is V-test by I-test, which is 1 by 3 millisiemens plus 2 by 3 millisiemens, which is basically 1 kilo. Okay. So now you could be asked a number of other questions. For instance, you could be asked the current flowing through this branch, or the circuit could be a little more complicated, and you could be asked for currents and voltages elsewhere in the circuit. But once you are able to apply the voltage source and carry out these calculations, you should be able to find any of those quantities. Okay. So in this particular example, the effective resistance turns out to be 1 kilo ohm.